What technologies were used at the Titanic Shipyard? Have you ever wondered how the Titanic was built? The construction at the Harland and Wolff Shipyard in Belfast was a remarkable feat of engineering. Let's take a closer look at the technologies that made this possible. First, the hull of the Titanic was constructed using over 2,000 large steel plates. Each plate measured up to 30 feet long and weighed several tons. These plates were rolled steel, typically 1 to 1.5 inches thick. The assembly method used was clinkered, meaning the plates overlapped to create a strong, watertight shell. Unlike modern practices, the plates were riveted together instead of welded, as welding was still in its early stages. Speaking of rivets, more than 3 million iron and steel rivets were used to secure the hull plates and internal structures. This process involved both hydraulic riveting machines and manual hammering. The hydraulic machines were a newer technology at the time. They used large pincers supported by overhead cranes to compress rivets tightly into pre-punched holes, ensuring a strong bond. The structural framework of the Titanic included a keel, which acted as the backbone of the ship. Large steel frames, or ribs, were attached to this keel. There were about 300 pairs of these ribs, each standing around 20 meters high. This framework provided the main support for the hull plates and helped shape the ship. To facilitate construction, a massive gantry known as the Arrol Gantry was built specifically for the Titanic and her sister ship, Olympic. This gantry stood to 128 feet high, 270 feet wide, and 140 feet long, weighing over 6,000 tons. It housed cranes that could lift heavy steel components and move workers efficiently around the ship during construction. The Titanic's propulsion system was equally impressive. It included 29 boilers with 159 furnaces that powered to massive reciprocating steam engines. These engines were the largest of their kind, standing nearly 40 feet tall and 9 feet in diameter. The engineering required for these components involved specialized industrial techniques and heavy machinery. The steel used for the Titanic was of good quality for its time, but it was later found to be more brittle in cold temperatures than modern steel. This characteristic contributed to the ship's vulnerability during the iceberg collision. The rivets also varied in quality, with some being wrought iron and others steel, which affected overall strength. From an archaeological perspective, the Titanic Shipyard is a significant industrial site. It showcases early 20th century shipbuilding technology on an unprecedented scale. The remains and records from the shipyard provide a glimpse into the materials, tools, and construction methods used to build one of the largest ships of its time. The combination of hydraulic riveting machines, giant gantries, and massive steel frameworks illustrates the industrial capabilities available during that period. These technologies blended traditional craftsmanship with emerging mechanization, leading to the construction of the Titanic.